Hi, welcome back to Coding with Doc. This session is going to be session 5. So in the first session, we've looked at sequences. On the second session was sequences. The third session was also sequences. So that's 3 sessions of sequences. We've done another on selection, and this is the last session where we're also going to look at selection and what this session will do. We'll do a predict, we'll do a modify, we'll do a make. But really the end of this game is making a basic kind of adventure game, and that's the aim of the session, and that's where we'll get to by the end of it. So it's about if and it's about selection, and that's where we're about to go. I want to, at the start of this session, do a few predict examples and a few kind of knowledge consolidation exercises. So you're just kind of making sure that you're remembering, and it's that act of remembering and that act of kind of working through things that helps things stick in your memory and become sticky and become something that you just learn. So first of all, what do we mean by a variable? Jot the answers down on a piece of paper, put it on a whiteboard. Even if it's just a memory exercise and you're thinking that's what it means, let's get each of these 5 answers down. So what's meant by a variable? What type of variable would you store your name as? What's a Boolean data type? What type would you store the number of eggs in a recipe as? And what type would you store the amount of flour in a recipe as? I'll leave you to just get your answers down to those. So on that first one, I would have said something along the lines that a variable is a container used to store values that change as it's running. That's why we call it a variable, because it varies what's in that container. The second question, what type of variable would you store your name as? A string. It's a string. It's a set of characters or a string. What's a Boolean data type? Now, we sort of have mentioned those as we're going through. Boolean data types are ones that hold 2 alternatives, true, false, yes, no, that sort of thing. The next one, what type would you store the number of eggs in a recipe as? An integer, a whole number. You can't have half an egg. And what would you store the flour as? A decimal. Yeah, and so the name for a decimal inside Python is to call it a float. In some other languages, it will be called a real number. Now, the next one I want to look at with you is this. If you were faced with that program, so score is an input and it's taking in the score. Score is 90, score is 80, 70, 60, 50, so on. What would happen for each of those answers? And let's work through that answer. So as I said, let's work through, and we put score equals input. What is the score? So we've got that first bit in, and then if score is less than or equal to 90, print a star. If score is greater than or equal to 80, print an A. Lost the little last end of that. If score is less than or equal to 70, print a B. If score is less than or equal to 50, then we'll print a C. And then, so there were 90, 80, 70, 50, good. And then we had an else condition that printed a D. So if I run that, it says, what's the score? And I put in that first score it suggested of 85. And watch what happens. Probably not what you'd think. So 85, it said A star. So let's try the next one. Run it. What happens if I put in 60 as my score? A star. Let's run it again. Let's put in 10 as my score. A star. Now, at this stage, all of you have said, hang on a minute, something's going seriously wrong there. What's going wrong? The answer is these are checking for a number, and this input is looking for a word. So that's part of this predict exercise, is being able to look for and trying to see errors before you press the run. So now if I did it, so I've told it it's a whole number, and I put in my 85, I get an A grade, which is kind of what we expected. Or I run it and I put in my 60, and we get a C grade, which is kind of what I suspect some of you might have thought the first time around. Or we try it and we put in a 10, and we run it, and it gives a D. And so all those look like they're doing it correctly. So let's turn back to a more abstract question before we go back to some more of these predict examples. So the question I'm posing is, what is indentation? And how does the if and else statement work? So what's indentation, and how does the if and else statement work? Now, we covered those on the previous session. And in response to that, I would say something along the lines of, indentations are the spaces at the start of the line. So you put those after the if and the else. And after the if, everything that's indented will happen if that's true. And then everything that's indented after the else will happen if the else is true. So it's just understanding that layout of the structure of that type of statement. Now, let's do another one of these predict type questions, and let's work through some more of those answers. So if we have that as a piece of program code, what will it do? And what does the and do? So in response to that, what that's doing is checking, do they have an age that's greater than or equal to 16, and they've bought a ticket? The has ticket is true. Because if they're older than 16 but they don't have a ticket, they can't come in. And if they're younger than 16 and they do have a ticket, they can't come in. So you need both of those conditions to be true in order for the and to work. So what that will do is put sorry you can't enter in that particular instance, because the age is below 15, even though the person has a ticket. Now, let's try another one. What will happen with this? Weather is sunny, is cold is false. What do you think it's going to print? And the answer to that would be, it'll print it's a perfectly sunny day, because it'll look at the weather and go, is the weather sunny? Yes. Is cold, if is cold, now it'll look for automatically, does that mean it's true? Where it go, it's sunny but chilly, but it's not true, it's false at the top on that second line. It says is cold is false, so it'll print the else condition, which is it's a perfectly sunny day, which is what indeed it's printed. Now, the next thing I want to do with you is to look at this particular piece of code. So I want to make this with you, and then having made it, I want to ask ourselves a question. What happens if we change the age to 16, but we change the ticket to false? What happens if we change the and to an or? How will that alter how things work? What if it's not has ticket? What does that do? So let's have a play with this piece of text. Let's make it. If you need to pause the video as we're making it, so that you can make it yourself and play with it yourself. That's great. But let's just have a look. Making it, it says age equals 15. Has ticket equals true. So that's a Boolean store. And then if age is greater than or equal to 16 and has ticket, so it's testing that Boolean piece of logic. Boolean, by the way, is just named after a man called Charles Boole, who was a professor of maths a very long time ago. His father was a shoemaker. He was out in Ireland, was the gentleman. So if you want to go and look up George Boole, and you want to look up that, you'll find there's some very interesting little videos on the life of George Boole online. And it shows you sometimes people devise things that are logic things that they never really see the use of in their lifetime. So they can see I've made, while I was busy chatting about Boole, the piece of code in question. And you can see it says, sorry, you can't enter. Now the questions were, what would happen if I changed it to 16 and ran it? It'll say I can enter. What will happen if I change the ticket to false? So now say I can't enter. I don't have a ticket even though I'm old enough. What happens if I change it to an or? I can enter. What happens if I change that back to 15? I can't enter now because I'm too young and I don't have a ticket. But if the ticket was the original way around, either one right with an or, it'll let me in. So the or changes what I'm testing there. It's not am I older than 16 and do I have a ticket? It's am I older than 16 or do I have a ticket? And either or are letting me in. Now, in terms of the not condition, I can do and not has ticket. Now that then changes it to can't enter, whereas if I change that to a false, it still means I can't enter. So that, in effect, the not condition stops both working. Now, if what I did round that is put that in brackets, then the question is, does that alter it? Does it alter it if I change it to true? No, it doesn't. So the brackets aren't changing anything either. The not condition is just jamming the whole thing up completely. So with that, we've looked at the investigate, and now I want to turn to just looking at two types of errors before giving you a make challenge. Theory here is there are these two types of error that you get inside computer code, and you'll hear programmers talk about. So a bit like when we talked about an algorithm or when we talked about a container, it's a word, it's kind of one of these big ideas that we're playing with. You've got these two types of error, one called a syntax error, one called a logic error. So a syntax error is an error with your code. So that might be a spelling mistake where you might have written pint instead of print, or you might have put print with a capital P, or you might have put it all in capitals. Those are syntax errors. In effect, they are spelling mistakes or errors in the way that you've written the code itself. Whereas a logic error is different. What a logic error is looking at one like that not example in the previous one, where we've made a mistake in how the code works, or a logic error being a mistake in kind of how we're testing it. So that early predict where we threw in the number, the logic of what we were doing was wrong. We were testing a word with a number condition. So logic errors are mistakes in the way something works. It's still working, but it's working in a way we wouldn't expect. Whereas a syntax error, it's just not working because there is a spelling mistake or an error of that nature. Now, this point I'm going to stop because I want you to spend the vast majority of the time in this session having a go at applying what we've just done. So some of you will have grown up knowing of these kind of storybooks. They were early games as well, where you create a kind of a story in text. And all I want at the moment is print statements for the story. Yeah. So print statements where you build up a story and then you ask, do you do this or do you do that? Do you do this or do you do that? And depending on which choice you give, then it does one thing or it does another, and it'll work through the different possibilities in terms of those different answers to things. So a lot of print statements, a lot of ifs and elses as you're going through explaining it, and I'll leave you to kind of work your way through that answer and think through how you want that to look. Now, if as you are doing that, you are stuck and you're not sure about how to do it and you've got a little bit lost in the whole thing, if you look at the last exercise talks about making a game, and I'll model something not dissimilar to this particular task.
Hi, I trust that you have had a little bit of fun doing that. Now, as a kid, I used to get those Find Your Own Adventure books bought for me and all sorts of things like that. And the aim behind those is that you were picking what to do at the end of the story, and that's the aim of this. And now I want to show you a piece of code that kind of follows that basic story arc.
So I'm going to try and work through a potential answer to this one. Now, unlike so many of the other exercises we've done, where there's been a really clear answer or a clear way of doing things, this one is a task that you could answer in a multiplicity of different ways. So I would have started with something like this. I would have started with print. Welcome to Doc's adventure game. And then you might drop her down a line. You might even want to put in a blank line. Now, there are quicker ways of doing that, but that's as good as any at this stage. And then you'd probably throw in something like, let's have the name or the hero name. So we call it hero name equals an input that says, what is the hero's name? And lets them type it in. And then that's going to store the hero's name as hero. So then you can put things like this. You could do a print that says hero name. Let's put this outside quotes to start with. Hero name. So if you've picked Sir Galahad under what's the hero called, it's going to say Sir Galahad is asleep in a large empty room. Print, the room is in your castle. Print, now you can see I'm no English teacher, so there's not much of a storyline here. So Sir Galahad's asleep in a large empty room, the room's in your castle, when suddenly a large knock sounds on the heavy oak door. Print, hero name, jumps up, so Galahad jumps up and runs to the door. Print, at the door is a young woman who offers either a sharp sword or a small dagger. And then you can do a kind of a choice. You could say answer 1 equals an input that says, do you want the sword or the dagger? Press 1 for the sword or 2 for the dagger. And so once you've done something like that, what you can then do is use those conditional statements that we were doing before that says if answer 1 equals, now you can put it in quotes, you can put it outside of quotes, it doesn't really matter. But if it's a 1, then you can say something where you go print, you hold up the sword and notice some neat little letters glinting in the morning sun. So then it's giving you something specific for the sword. And then you can say object 1 equals sword. Could give it more of a name than that if you wanted to, but it's giving you that first object. And then you could say else print. Now this is, you've picked the dagger. Yeah. Now by using else rather than an elif2 and then an else, it means that the player has got to choose either the sword or the dagger, which was kind of in the hinge of the question. If you wanted to have 3 options, you'd obviously have sword, dagger, and then maybe an option 3 for rejecting both. Now, you then have a print that says you take the dagger and realize just how sharp it is. Then object 1, so same object, is now a dagger. So you've given it then that ability to kind of take an object, to look at what that object is and to run that through. So you've got a simple adventure there where that's kind of developing. Now, then you might do, and so you ideally build up the story a bit better than this, but you do print a shout from downstairs makes you realize that there is an incoming threat. Print, you step outside the door to be confronted with an angry knight. Now, again, answer 2 equals an input. Do you want to attack or run? Press 1 for attack or 2 to run away. So there you're making them again pick, are they going to do an attack or are they going to run away? And then you go. So that's stored that as an input as answer 2. So if answer 2 equals 1, so now this is the option to stand and fight. Yeah, you go print you pull out your, and then comma object 1. So this is going to be either your dagger or your sword. Yeah, and stand ready for the attack. Print So you can do multiple statements inside this print. So print, the knight lunges forwards. You neatly sidestep and strike hard. Print, your, and now this is going to be dagger or sword. Strikes clean, and the knight falls to the ground. So if on this occasion you chose to attack, then it's a guaranteed win. Now, later down the course, I can show you how to do things like introduce an element of randomness. So whether you'd win there or lose there will be a random decision. But at the moment, what we're doing is experimenting with this sequence, these sorts of prints and inputs, and these if statements where you're choosing between one thing or another thing that's allowing you to build up this sort of a story. Else, and then you've got to do your print and run. So you go print, you scream loudly, and the knight pauses. Print, you step back and slam the heavy oak door. Print, without a sound, you run to the hidden door beside your bed and make good your escape. So you can see there how I'm taking this idea of an if statement and an else statement, and each time I'm indenting, like on line 11 and 12, or on 14 and 15, or further on 20, 21, 22, or 24, 25, 26, those are the bits that are indented that match the choices I'm making inside the if statement. So 20, 21, and 22 are indented because that only happens when I choose to attack. And 24, 25, 26 are indented because that only happens if I've pressed 2 to run away, and it goes down that else statement. And each time I don't want it, then continuing inside just that part of the program, the runaway bit, I can now go back to the main story. Print, the threat seems to have subsided. Yeah, so you ran away or you attack the knight, and both are giving you that option. So you can see there you're building up this story. Now, I've given you the start of one, and I'm no English teacher, and I've not sat there and given you a great big long story here to go with, but it gives you the essence of how to do this particular task.
So this now takes us to the end of session 5. And on session 5, what we've looked at is sequence and selection. So sequence where we're putting commands one after another, and selection where we're choosing, do we do this or do we do that? So we're making a choice. Do we go this way or do we go that way? Or sometimes more than just a straightforward 2 choice, a 3 choice, where you might put in a command called an elif command in the middle. What we're about to do on the remaining sessions is look at the different types of loop. So there are really fundamentally 2 types of loop that we're going to cover on this particular course. There'll be other courses that will cover more types of loops than these, but this particular course we're going to use a loop called a for loop and a loop called a while loop. And a for loop will go through something for a set number of times. So you might say, I want you to run around the room for 3 times. So it will go around 3 times. And the other one might be, I want you to run around the room while I've not blown my whistle. So a while, you don't know how many times you're running around, but you know what the symbol is to stop. So the while loop does it indefinitely, does it on and on and on until they get that symbol to stop. And so that's the difference between the two loops, and they've both got a real place inside programming. We're going to do those in the next session. If you want to keep up to date with this series, as always, subscribe below. It helps both of us to keep in touch with one another, and I'll be very grateful for those subscriptions. Thank you very much.